This is Dr. J. Suresh Goud, Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, we are going to discuss about the course description of our course, Probability and Statistics. This will come in Program BTech second semester. The content of this video is, first we are going to discuss outcome-based education and Bloom's taxonomy and what is course overview, what are the course objectives and course outcomes. Similarly, we are going to discuss about program outcomes and program specific outcomes and course syllabus of probability and statistics. First, we are going to discuss what is outcome-based education. It's a student-centric educational model that maps or measures students' performance at all the levels. That is called outcome-based education. See, the OBE model aims, what is the aim of OBE is to maximize the student learning outcomes. To maximize the student learning outcomes by developing their knowledge and skills. The main characteristics of outcome education is we have three types of competence. One is practical characteristic and second one is fundamental characteristic and third one is reflective characteristic. What is meant by practical characteristics? So in these practical characteristics, we have to know how to do the things and ability to make the decisions. That is the practical characteristics. And understanding what you are doing and why you are doing is nothing but fundamental. And reflective characteristic means learn and adapt through the self-reflection. So apply the knowledge appropriately and responsibility. So these three are main characteristics of outcome education. And Bloom's taxonomy. This is the taxonomy of educational objectives known as Bloom's taxonomy. The educators often use Bloom's taxonomy to create learning outcomes that target not only subject matter, but also depth of the subject they want to study students to achieve, and then create the assessments that accurately report on students' progress towards these outcomes. This was introduced by Bloom's in the year 1956. After that, his student, the Anderson, developed this Bloom's taxonomy in the year 2001. And the Bloom's taxonomy comprises three learning domains. One is cognitive domain, and second one is affective domain, and third one is psychomotor. This assigns to each of these domains that corresponds to different levels of learning. And it is important to note that the different levels of thinking defined with each domain of the taxonomy are hierarchical. The Bloom's taxonomy is a powerful tool to help the develop learning objectives of the students because it explains the process of how we are learning. And the Bloom's taxonomy, we have 6 levels. The first level is remembering level. In this remembering, the student has to recall the relevant knowledge from the long-term memory. After reaching this level, the next second level of the Bloom's taxonomy is understanding. Here, making sense of what you have learned in the remembering. That is called understanding. After completion of remembering and understanding levels, we are going to use applying level. Use the knowledge. Whatever the knowledge you gain in understanding and remembering, use that knowledge in new ways. That is called apply. And analyzing or analyze means breaking the concept. Whatever the knowledge you understood, that is breaking the concept into different parts and understand how to each part is related to some other. That is called analyzing. See, breaking whatever the concept you understood, that concept you divide into parts and try to understand how to each part is related to other part. That is called analyze. After analyzing, the evaluating. Evaluate means making the judgments based on a set of guidelines. And finally, we have creating, putting information together in an innovative way. That is called creating. So these are the 6 Bloom's levels in the Bloom's taxonomy. First one, remembering, understand. Second one, applying, analyzing, evaluating. and creating. And in probability and statistics, the course overview of this subject is, it is a branch of mathematics, deals with modeling uncertainty and statistics, regression lines and correlations. They also have wide varied applications in the telecommunications and other engineering disciplines also. We are going to use these topics. The course covers the topics of probability and statistics with applications. The course includes the topics random variables and probability distributions, hypothesis, and linear regression. This is an emphasis placed on the real world applications to the engineering problems. So these are the main course overview of probability and statistics. What are the objective of this probability and statistics? That means what the students will try to learn after completion of this course. That is called course objective. So we should give this course objective as a teacher. We need to give before starting the course. We have 4 course objectives. The first course objective is the student will try to learn the theory of random variables and basic random variable distributions and their applications. And the student will try to learn the methods and techniques for quantifying the degree of closeness among 2 or more variables and the concept of linear regression analysis. And the student will try to learn the estimation statistics, hypothesis testing, which play a vital role in the assessment of the quality of the materials. This is very important. And the student will try to learn the statistical tools which are essential for translating an engineering problem into probability model. So these are the main course objectives the students will try to learn. These course objectives will decide before going to start the course. Course of outcomes. What is the meaning of course outcome? The course outcome means after successful completion of the course, the student will be able to try to understand what are the outcomes. So we have defined nearly 9 course outcomes in this course. The first outcome 1. The course outcome 1 is explain the concept of random variables and types of random variables by using suitable real-time examples. Explain the concept of random variables. That means what is the meaning of random variable and what are the different types of random variables by using suitable real-time examples. So this is the understand level. And CO2, course outcome 2, calculate the expected values, variances of the discrete and continuous random variables for making decisions under randomized probability conditions. The knowledge level is applied. And course outcome 3, interpret the parameters of random variable probability distributions, such as 3 different distributions, binomial, Poisson and normal distribution, by using their probability functions, expectation and variance. This is also under understand level. CO4, apply the concept of discrete and continuous probability distributions in the topic, and CLT for solving real-time problems under probability conditions. This level also under apply. And CO5, interpret the results of bivariate regression as well as correlation relation for statistical forecasting. This also under the knowledge level of understanding. Identify the role of types of statistical hypothesis, types of errors, sampling distributions of means and confidence intervals in hypothesis testing. This is also apply level. Whatever the different types of statistical hypothesis the student has learned, that will be identified, and sampling distribution of means and confidence intervals in hypothesis testing. And CO7 is apply the test of hypothesis for both the large and small samples in making decisions overall statistical claims. This under apply. And CO8, test for the assessment of goodness of fit of the given probability distribution model by using characteristic chi-square distribution. This is under analyze, because after giving the problem, we should divide the parts. Then we can make the first part is related to other part or not. That's why it is under analyze. And CO9, make use of R software program package in computing confidence intervals, regression lines, and hypothesis. This is also under apply. CO10, select appropriate statistical methods for solving real-time engineering problems governed by laws of probability. This is also under apply. And we have 12 program outcomes in the BTech level. The first one is engineering knowledge. Second one is problem analysis. Third one is design or development of solutions. Fourth one is conduct investigations of complex problems. Fifth one is modern tool use. Sixth one is the engineer and society. Seventh one, environment and sustainability. Eighth one, ethics. Ninth one, individual and teamwork. 10th one, communication. 11th one, project management and finance. 12th one, lifelong learning. These 12 program outcomes defined in BTech level. And now those program outcomes defined. First PO1, engineering knowledge. Apply the knowledge of mathematics, science, engineering fundamentals, and engineering specialization to the solution of complex engineering problem. The strength of this PO1 is 3 in our probability and statistics subject. This will be assessed by either CIE or PIS AAT. And the PO2 also mapped with the strength 2 for our subject, the problem analysis. And PO4, not PO3, PO4 also mapped with the strength 1 for our probability and statistics, that is conduct investigations of complex problems. PO5, modern tool usage. This is also we have strength 3. And this is the justification of our CO PO mapping direct. Our outcome CO1, that is a course outcome, and this is the program outcome. The justification for mapping, the students will be able to explain the concept of random variables and their role in solving complex engineering problems involving random events and uncertainty by using mathematical functions. That means we have a relation between CO1 and PO1. Similarly, CO2, our course outcome 2 is mapped with PO1 and PO4 with the competence 1. CO3 mapped with PO1. CO4 mapped with PO1 and PO2. CO5 mapped with PO1 and PO4. Like that, we have mapped with CO, all COs with our PO1. PO1, PO2, PO4, PO5 only mapped with our COs in this subject. And the syllabus of this probability and statistics is in the module 1, totally 5 modules. In the module 1, we are going to discuss random variables. Module 2, probability distribution. Module 3, correlation and regression. Module 4 and module 5, test of hypothesis with the different tests. In module 1, we are going to discuss the basic definition of random variable and discrete and continuous random variables. What is probability distribution and their types. That means probability mass function and probability density function. And in module 2, binomial distribution, Poisson distribution, and normal distribution we are going to discuss in module 2 with the mean, variance, mode, and median of all the 3 distributions. And correlation and regression in module 3, the Cole-Pearson's coefficient of correlation. That means we need to find the strength of the relation between the 2 variables by using the correlation. Regression means we can same the relation between 2 variables, but by using lines of regression. And the sampling distribution also we have definition of population, sampling, errors, null hypothesis, test of hypothesis, types, 2 different types of errors, type 1 and type 2 errors. These are the textbooks. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.